Okay, here we go with lecture 11b. This is the second part of the discussion about simple rules, the derivative of a product and the derivative of quotient. So that's what we're going to do now, is the derivative of quotient. So suppose we have this function q of x, q of course standing for quotient, and q is the quotient of f of x and g of x. And supposing that f and g both have derivatives, then what would the derivative of the quotient be? What would q prime of x be? Well, once again, I'll tell you what the answer is rather than just prove it, and we'll do an example, and then I'll go and show you why it is. Okay, so what is the derivative of quotient? And the way that I remembered it, the way I learned it rather, and the way I always remember it, is that you always start with the denominator. You always start with the bottom. So it's exactly the denominator times the derivative of the numerator minus, and don't forget that it's minus, not plus, the numerator times the derivative of the denominator, and then, you're still not done, the whole thing is divided by the denominator squared. So g of x, whatever g of x is, that has to get squared. Horrible formula, kind of hard to remember, but you just have to remember it, memorize it. It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared. There have been all kinds of ways that people have learned this, cute ways. I don't go for any of them, but if they help you, fine, go for it. There's, some of them call this high and ho, and then you can go high d ho minus ho d high over ho ho. And if that helps you, then fine, do it. But to me, it's much easier to think about what's going on if I remember to start with the denominator and then multiply by the derivative of the numerator and then subtract, it's minus, the numerator times the derivative of the denominator, and then the whole thing is divided by the denominator squared. Notice that you're never multiplying two derivatives together. Okay, here it's the derivative of the top that's multiplied by the bottom. So it's the denominator, the bottom times the derivative of the top, minus the top times the derivative of the bottom. Okay, so they're always mixed. You're never multiplying two derivatives together. And then the whole thing has got to be divided by the denominator squared. All right, so let's look at an example of this. And this isn't a bad one to look at. Suppose that you want the derivative with respect to x of this quotient, x squared minus 2 divided by 2x plus 1. Okay, well, it's a quotient, so we can use the quotient rule. So we just start with the denominator, 2x plus 1. And then what you should do is always have parentheses around that denominator because it's usually a complicated expression. And then usually you should put parentheses to begin with. Now in this case right now, it's not going to be that important because the derivative at the top is easy enough to compute, and it's just 2x minus 0, of course. and there's nothing more to do it, so I didn't really need those parentheses. But most of the time you do. All right, so it's the denominator times the derivative of the numerator minus, and then you've got to go with the numerator, x squared minus 2, times the derivative of the denominator. You know what? I think I might change this problem a little bit, make it a little harder. It's too easy right now, and it's too easy to not see where people will make a mistake. So let me make this, instead of 1, let's make it 7x cubed. All right, just to make it a little bit more interesting. So now when I get the denominator, it's just 2x plus 7x cubed over there, and then here I want to make the numerator times the derivative of the denominator. The derivative of the denominator now is going to be 2 plus, now I need the derivative of that guy, which is 3 times 7 times x to the 2. So that'll be 21x squared. Now you might wonder why I changed the problem to make it that much. It's not that much more difficult, really. But what I wanted to show you was right here. When you multiply that numerator times the derivative of the denominator, you really have to put those parentheses there. Because what's going to happen if you don't is that you're going to forget that this 2 is not the only thing that gets multiplied by x squared minus 2, but also this 21x squared. In other words, this has got to be multiplied out or FOILed if you actually were going to do that. So this is the entire quantity. And then you've got to divide that by 2x plus 7x cubed. Not quite. That's the denominator, and you got to do it over the denominator squared. Okay. Now, I've complicated the problem enough that I don't really want to do the next step, which is to simplify. But you can see that when you multiply this out, there's some terms that are going to collect. Like, for instance, this 7x cubed right here, multiplied by 2x, is going to end up giving me a 4th degree term, 14x to the 4th. And I'm going to have a 4th degree term over here, too. Here's a 21x squared that's got to get multiplied by x squared. So I'm going to end up with 21x to the 4th. So I don't really want to have two 4th degree terms up there, so I would have to bring them together. But to bring them together, I'd have to multiply all this out and then FOIL this stuff, right? And that's just too much stuff for me to do right now. But you'd have to do that and collect all the terms, and then that would be your, once you simplify that, that would be your final answer. If you didn't feel like doing this on a test, and you had a problem that was complicated, and you had to use the quotient rule, and you got to this point, I can absolutely guarantee you that if you get this far, you will not lose more than 1 point, if that. Chances are, well, on a problem like this, I wouldn't take off, but you might lose a point if there's a simplification that would make it really, really nice. Let's go back and do the other problem, because I realized now that they intended for you to do the simplification. And so if the problem was this one, x squared minus 2 over 2x plus 1, this wouldn't be a bad test question, and then you'd need to simplify it. When you use the quotient rule, 9 times out of 10, there is a simplification that you can do. So once again, it's the denominator times the derivative of the numerator, in this case 2x, minus the numerator, x squared minus 2, times the derivative of the denominator. This time the derivative of the denominator is just 2. And all of that is divided by the denominator squared. Okay, at this point I am going to simplify, so from here on there's no more calculus, it's just algebra. Christie's rule, don't multiply unless you absolutely have to. That 2x plus 1 squared in the bottom, there's no reason on earth to multiply that out. What you would like to do is to cancel off one of these guys, and often you can do that. Often you'll see that after you've used the quotient rule, one of these guys in the denominator ends up canceling. Well, if you've multiplied that out, there's no way in the world you're ever going to see it cancel. So leave it in its factored form, 2x plus 1 times 2x plus 1. And maybe on a good day, if you're lucky, this thing reduces to something that's got a factor of 2x plus 1 in it. All right, so what do you have? Looks like I'm going to have to multiply this all out. So I get 2x times 2x, which is 4x squared, plus 2x times 1, minus, and now here's what I always do. When you've got minus and it's going to be complicated, I just put an open parenthesis here and just multiply it out straight. So I don't try to be fancy with distributing the minus just yet. So this is going to be minus the quantity, 2x squared, and then minus 4. I don't try to do too much in my head. It's easy to make a mistake that way. Divided by 2x plus 1 squared. Okay, so now I'll go ahead and distribute this minus, and everything's clean here. I can see what I've done. So I'm going to get 4x squared plus 2x minus 2x squared minus 4 makes it plus 4. And all of that is divided by 2x plus 1 squared. And simplify that. All I can do here is get the 4x squared minus 2x squared, which gives me 2x squared. And then I get 2x plus 4 still there. A lot of even numbers here, aren't there? Maybe I can factor out a 2 usefully. Let's see what happens when I do that. Factor out a 2, and I get x squared plus x plus 2 divided by 2x plus 1 quantity squared. Now it'd be nice if this thing here factored. Unfortunately, I don't think it's going to factor. Wonder what b squared minus 4ac is. B squared is 1 minus 8. No, this thing is not going to factor. So we're stuck with it. Don't try to make it factor when it doesn't. Right? It would have to, if it factored nicely, it would be x plus 2 times something. But you can see that that's not going to work. It's got to be, it would add up to be 1. You can't get them to add up to be 1 if one of them's 2 and the other one's 1. So this is it. This is the best you can do. And whether you factored out that 2 or not doesn't make any difference. This is a perfectly good answer. This is a perfectly good answer. Don't do any more factoring because there's nothing more you can do here. Don't do erroneous factoring. Okay? Anyway, that's it for the quotient rule. Now, let me do one more problem. Oh, excuse me. No, before I do a problem, I need to show you why this is true. Why is this horrible, nasty formula for the quotient rule the way it is? Now, I have my own way of proving this, which I think is kind of neat. Let me do it this way. Suppose that I want the derivative right now of this function, 1 over g of x, just by itself. How would I take the derivative of that? I don't have any rules for this. I mean, it is g of x to the negative 1. The high school rule doesn't quite work because it only works when I've got g inside, or excuse me, x inside. So what I've got to do is use the definition. So this derivative is, by definition, the limit as h goes to 0 of the function evaluated at x plus h. So I've got to go 1 over g of x plus h minus 1 over the function, minus the function at x, all divided by h. What I'm doing here is using the definition of limit, the definition of derivative for a function like, let's just make it r prime of x. R prime of x would be the limit as h goes to 0 of r of x plus h minus r of x all over h. Using that definition and thinking of r as this ratio, 1 over g of x, okay, then r is 1 over g of x. So r prime, the derivative of r, is the limit of the difference quotient. So I have to calculate r of x plus h. What does r of x plus h mean? It means the function, which is this ratio, evaluated at x plus h. So you replace x by x plus h, and this is what you get. Then you have to subtract r of x, which is just that thing, that ratio. That's what I've got, and the whole thing is divided by h. Okay, what do we do now? Well, looks to me like the only thing I know how to do is get a common denominator and subtract. So we'll do that. This is going to be the limit as h goes to 0 of, well, the common denominator is easy enough, g of x plus h times g of x, but the numerator is going to be cross-multiplied, g of x minus g of x plus h. And the denominator is the common denominator, g of x plus h times g of x. And then I've still got this divided by h, but I don't want the compound fraction, so think of that as h over 1, flip and multiply, so I end up with the h down here. If that bothers you, go through it yourself and verify that from here to here is nothing but algebra. There's no calculus done at this point. Okay, now I'm going to do a little bit of sneaky algebra. I'm going to take this limit and recognize that g of x minus g of x plus h is almost the same as g of x plus h minus g of x, except backwards. So I'm going to write it backwards, but it's going to cost me a minus. So I can put a minus there. And then I'm going to divide this by h, and I'm going to stick the 1 over g of x plus h, g of x, over here. So just check and make sure that I didn't cheat. Everything here is the same as what's up there. I switched the order of the two terms in the numerator, which I can do if I put a minus in front. Just double check that. Distribute this minus, and you'll see it's minus g of x plus h. That matches here. And then minus minus g, which gives me plus g. So this is really what I had up there. I just wrote the bottom in a different order now. And the neat thing is, this minus I can move wherever I want. And look at what's left over here. The limit as h goes to 0 of this times this. The limit of a product is the product of the limits. So I take the limit of the first thing. And we've seen this before. The limit as h goes to 0 of this difference quotient is exactly the derivative of g. So I get g prime of x times, then that minus can just go over there, minus 1 over, and then we've been here before. What happens as h goes to 0? This gets closer and closer to g of x because g is continuous, and so this is g of x, this is g of x, so we have g of x quantity squared. So I have a formula. The derivative of 1 over g of x is g prime of x times negative 1 over g of x squared, which seems like a horrible formula. Let me rewrite what I'm doing here. The derivative of 1 over a function is that. Now, what good is this? Well, maybe you've guessed by now what I'm about to do. What I'm really interested in is not that, but I'm interested in the derivative of f of x over g of x. Any idea how I'm going to get that? Well, those of you who are brilliant or clever probably figured out that I'm going to take the derivative of f of x times 1 over g of x. And how am I going to take the derivative of this? 2 words, the product rule. So the product rule tells me that to take the derivative of the product of these two, it's going to give me the first times the derivative of the second. What's the derivative of 1 over g of x? I just did it. So I can just copy this. So it's g prime of x times negative 1 over g of x squared. First times the derivative of the second, plus the second, 1 over g of x, times the derivative of the first. What's the derivative of f of x? I don't know, but I can call it f prime of x because that's what that means. That's the derivative of f. Okay, so I've got a formula for the derivative of a quotient. Let's collect terms a little bit. I've got a fraction over here. I need a common denominator. What's the common denominator going to be? Looks like g of x squared to me. So I'm going to have to multiply this term by g of x over g of x to get to the common denominator. So the first term is going to stay the same, except I'll have a minus of minus f of x g prime of x and then I'll have a plus, and over here it's going to be f prime of x, g of x. And lo and behold, you've got your common denominator, everything is right. And if you read this in English in a slightly different order, here's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. So there you have the quotient rule proved for you. Okay, one last example, and this is a bunch of problems that you'll see are stated this way. And sometimes they throw people, but it's remarkably easy. Don't just panic when you see a problem that you've never seen before. Just think about it a little bit and ask, what are they talking about? What does this mean? What does this mean? So here's the problem. See if you can figure out how to do this before I tell you. They're giving you some information. Suppose that f of 2 is equal to -3, and g of 2 is equal to 4, and f prime of 2 is equal to -2, and g prime of 2 is equal to 7. So suppose that you're given all of that information, and the problem says find h prime. Well, now this is a little weird. H prime of 2, where h of x is g of x divided by 1 plus f of x. Now this is weird for a lot of reasons. First of all, they now turned h into a function. So h is no longer that thing that goes to 0. H is now the name of a function. And unfortunately, people do that. I apologize, but I took this problem out of the book. So you might see stuff like this. Don't allow it to throw you. H can be a number sometimes and a function at other times. Just deal with it. Okay, so how are we going to do this problem? What is it? What are we supposed to do? The question says find the derivative of h. Find the derivative of h. Well, how do I do that? The derivative of h at 2. Well, if I want to know the derivative of h at 2, normally the best way to do that is to find the derivative of h at x and then replace x by 2. So can I find the derivative of h at x? What's h, first of all? Well, h is given by this formula. So can I calculate h prime? Sure I can. Because what kind of function is this? It's a quotient. And I just learned the quotient rule. So I can just crank out the quotient rule. What is the derivative of a quotient? It's the denominator. Here's the denominator. Whoops. F of x. The denominator times the derivative of the numerator. What's the derivative of g? I don't know. So we just write g prime. I can do that. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. What's the derivative of 1 plus f of x? Well, I know what the derivative of 1 is. That's 0. Plus, what's the derivative of f of x? Well, I don't know that, so the best I can do is write f prime at x. So this is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and you still have to divide by the denominator squared. 1 plus f of x quantity squared. Okay. Now I suppose I could simplify that, but you know what? I think I am ready to calculate h prime of 2. Because what does h prime of 2 mean? It means take the formula for h prime, which I've got here, and plug in x equals 2. So we can do that. This is going to be 1 plus f of 2 times g prime of 2 minus g of 2 times, and I know 0 plus anything is 0, so is that anything? So I can drop the 0 and just write f prime of 2. And then that whole thing is divided by, replace x by 2, there's no x's there, 1 plus f of 2 quantity squared. And folks, you can now look all these numbers up because I think they gave every one of them to you. So this is 1 plus f of 2 was given to be negative 3 times g prime of 2, g prime of 2 is 7, minus g of 2 is 4, and f prime of 2 is minus 2. And then you got to divide that by 1 plus, what's f of 2? F of 2 is minus 3. So 1 plus minus 3 quantity squared. Okay, now I'm ready to calculate that. So this is going to be 1 minus 3 is negative 2 times 7 is negative 14 minus, this is going to be minus 4 times minus 2, which is plus 8. And that's going to be divided by 1 minus 3 is negative 2, squared is 4. So this is minus 14 plus 8, which is negative 6 over 4, which reduces to minus 3 over 2. And that is it. That's the answer. Okay, well, that's it for now. See you Monday morning.